Hey guys, Mr. Ruth here. Today's lesson is going to be in three parts, and it is about first solving by graphing, which many of you have done before. So this is going to be the short part, and then we're going to talk about something called optimization, which is a really cool idea. One of the greatest applications of math, of algebra and calculus. It's going to set the stage for some things you're going to be studying in calculus your junior or senior year. So hopefully you find it interesting. And there's some real world problems that we get to solve along the way. All right, but starting with graphing. Many of you solved by graphing back in Algebra 1 in 8th grade. We teach you all these methods to find vertices and find roots by factoring and by completing the square and the quadratic formula. But ever since, about the middle of the 20th century, we've had technology that'll do this for us. The biggest mistake I see with some of my juniors and seniors is I'll give them a question and maybe at some point they have to solve a quadratic inside of a larger question, a calculus question or a pre-calculus question, and they forget that they can just pull out their calculator and figure it out on the calculator. In appropriate situations, don't be afraid to use technology. We are not against using technology in solving quadratics. If you're in the real world and you're doing some of this math someday, you're not going to be sitting there factoring. Most of the time, you're gonna actually use technology. So let's look at something like this. Let's say in example 1, I want to find the roots and the vertex of this parabola. So I've got y equals 0.0032x squared minus 0.6x plus 22. So you're immediately saying, I don't want to factor this thing. It doesn't have integer coefficients. And that's what you find in real world problems. You don't find nice clean integers most of the time. Most of the time you find decimals and things like that that you need to deal with. So, what we're going to do is we're going to just go ahead and graph this on Desmos. So I go over to Desmos and I type in y equals 0.0032x squared. I use shift 6 for the squared minus 0.6x plus 22. Now, first thing I notice, let's bring Desmos into the full screen. The first thing I notice is I can't even see my parabola anywhere. I'm like, where is it? So, Desmos is pretty good for that in the zooming. I can either use this command, or if I've got a scroll wheel, I can scroll out. But, I can see what's going on here. So now I want to scroll in and focus on the key parts of the parabola. All right, so what do I care about in a parabola? Well, most of the time I care about the roots, which I can find in Desmos just by clicking on, and I care about the vertex. So I've kind of honed in on the parabola here without much need to go into the wrench and change the scale. That would be the next problem. So what do I do if I'm asked to sketch this? Well, if I'm asked to sketch this, when you solve a problem using technology, the best practice is to make a sketch of the computer screen and write calculator or Desmos so that the teacher or whatever you're doing, or just for yourself, you know that you've solved this using technology. So in a problem like this, I might do something like this. I draw my x and y axis, and looking over at Desmos, and where this is, the vertex is just a little bit below the x-axis, but it's pretty far along. So I'm going to draw this so it kind of looks like the screen I see. It's not the cleanest drawing here, but it'll do. And then I always want to label the vertices. So I want to say, okay, well, what is the vertex of this parabola? Okay, it's 93.75 and negative 6.125. What are the roots? 137.5, comma 0. Over here, 50, comma 0. That one's easy. And I'm going to write, calculator or Desmos to show that this is how I got the solutions. And that's best practice. So then what are the roots? The roots are 50 and 137.5, and then the vertex is 93.75, negative 6.125. If you've already labeled it, you might not need to write it again. It just depends on the scenario. I would accept this as a complete answer without the additional labeling. All right. Using Desmos, there's some step-by-step instructions here. And these are going to come into play for example 2. So let's get rid of example 1 and type in our next one. Now this one gives us negative 4,000x squared minus 25,000x plus 45,000. Now, the first thing that you notice with this parabola is it's really skinny. Now, normally what we want to do is we want to scroll out so we can see the vertex. So I'm going to scroll out, and I know that this has a negative a value. So I know it's going to be a down opening parabola, so the vertex is up here. But you can see, just by scrolling out, I really don't get a sense of what this parabola looks like. It almost looks like a line. So the problem I'm having is that it's too narrow, right? It's too narrow. So what I want to do is I want to change the scale on the x-axis to expand it out. So what I'm going to do is I scroll into, let's say, here, and I say, you know what? I don't want to see all this stuff out here. That's no good to me. I just want to see from about, well, if this is negative 10,000, each one of these blocks is 2,000. So I want to see from negative 2,000 to positive 2,000. So in Desmos, I go to the wrench. Down here in x-axis and y-axis are where I can adjust my scales. And I'm going to change this to negative 2,000 to positive 2,000. And that gives me a much clearer picture of the parabola. But what do I notice? I notice it's still way too skinny. So I want to go ahead and reduce it again. So if this is 200, then this would be 100, this would be 50. I'm going to go, negative 25 to positive 25. And again, this is kind of an iterative process. You're not going to just do this once and it's going to be perfect every time. It's better to just kind of try something and see how it works. Okay, so I've got something I can actually see that looks like a parabola. So what do? I click on my 3 dots to find the roots and the vertex. And now I'm ready to sketch. Now, one thing I didn't talk about in the first sketch that I should have is lots of time it's good to provide some sort of scale. So in other words, up here, this is at 80,000. So I want to get some sense of the scale. So I might write 80,000 and 40,000. And then over here, I might write, 20, 40, so that somebody looking at this has a sense that I really have changed the scale from a normal XY scale. I very much kind of pulled it apart and zoomed in, stretched it horizontally with my zoom. All right, so then I'm going to draw the parabola itself, just pick it up in a different color. My vertex is up here. Like so, and then it's crossing the y-axis and going like so. Now I still want to label my roots. So my roots here are negative 7.7090. And my other root, you can use arrows or other devices to help yourself label. That's 1.459, 0. And then finally my vertex is at negative 3.125, negative 3 1/8, comma 84,062.5. Okay, and this might have benefited from a little arrow, but this is a reasonable sketch. This gives me all the information I would be looking for. You ready to go ahead and do the first 4 problems of the homework and answer the few questions below in the notes?